terms, if I were to add 13 values, and you can see that, yeah, the sum is changing. Oh, excuse me. I'm not going to do this, but you can read it yourself. Student is offered a job, math teacher, that lasts 20 hours. It pays $4.75 for the first hour, $5 for the second hour, and then $5.25 for the next hour, and so on. So how much will the student earn in total? So clearly, the student's pay is going up by 25 cents. So we know the first hour is $4.75. The difference is 0.25, and we know n is 20 because the whole sequence is 20. So let's do the sum. So by the sum of 20, and I plugged into the equation, I got $142.50. So is that good? Is this kid making money, or is the teacher taking advantage of this kid? Let's see, 142.5 divided by 20. So an hourly rate of $7 and I don't know, let's read it. 12 cents or 13 cents. If you're rounding up, $7.13. It's not bad actually, considering you're starting at $4.75. So yeah, teacher could just from the beginning be paying $7.13. Hold on, what's the calendar saying again? So I'm double check. Recursion. Okay, no. So I did this. I did this. I did this. I did this. I don't want to do recursion. I hate recursion. We kind of exploring patterns is dumb. Okay, yeah. Okay, yeah. Oh, annoyance, annoyance, annoyance. Let us do this then. So they expect me to do all of these 4 lessons, which is not happening because we only have 10 minutes left. But they are videos, so watch the videos. A recursion formula is the hardest lesson in this unit. What is a recursive function? Basically, you're gonna write the same patterns, but in a different way. The equation is going to be something called a recursive function. What is a recursive function? Formal definition: a formula by which each term of the sequence is generated from the preceding term or terms. There's a nice video about the Fibonacci sequence. That's what a recursive function is, and a good example. And like golden ratio and stuff. Usually I would go into detail and tell you about life and the cool things in nature. But we don't have time to do any of that fun stuff, unfortunately. So find another video. Google Fibonacci sequence, Google golden ratio. Watch a nice cool video on YouTube about it. All right, write the first 4 terms of the sequence. So here, T1 is 7. So they're automatically giving you the first term. They're like, okay, the first term is 7. We're starting at 7. Then they're saying the next terms will follow this formula. Tn equals Tn minus 1 minus 2. So the second term, T2, is going to equal, well, T2 is when n is equal to 2, right? So if n is 2, this is going to be 2 minus 1. And that's the same thing as, what's 2 minus 1? That's just the same thing as T1 minus 2. And we know that T1 is what? 7. That was given. 7 minus 2. So T2 is equal to 5. T2 is equal to 5. What if I want to get T3? Well, T3 is going to equal Tn minus 1. So that's going to be 3 minus 1. Sorry, minus 2. And 3 minus 1 is the same thing as T2 minus 2. And T2 is 5. So that's going to be 5 minus 2. The answer is 3. So if you haven't figured it out, a recursive function is written such that you are using the previous term to get the next term. So T4, for me to get T4, I need to have T3. There's no way for me to do this without finding T3 first. So I know it's going to be T3 minus 2, and T3 is 3 minus 2, which is 1. And obviously T5, once you have a pattern, you can probably write the pattern. So I know the first value was for 7, next value is 5, next value is 3, next value is 1. Now I can kind of do the pattern and be like, okay, well, it's probably going to be -1, -3, and so on. But how did I start out off with? I used this equation. So yeah, that's the recursive function. Let's do the exact same thing now. Just so you know that they don't have to be so simple. It can be a little bit complicated too. So here the first value, T1, is 5. That means T2 is going to equal 2 times T1 plus 4. And we know that that's just 2 times 5 plus 4. 10 plus 4 is 14. That means T2 is equal to 14. T3 is basically going to be 2 times T2 plus 4. And we know that T2 is 14, so 2 times 14 plus 4 is 28. 28 plus 4 is 32. That means my T3 value is 32. And see how I jumped up quite a bit? What's my T4 value? T4 is going to be 2 times T3 plus 4. And we know that T3 was 32. So that's going to be 64 plus 4, which is 68. So there we have the next few values. What did it ask us actually? Let's do one more. 14, 32, 68. Yeah, we did it. Something else that you should be aware of is that you can even have recursive formulas written in function notation. So function f of n is equal to f2 times f of n minus 1 minus 7. It's exactly the same thing as the previous example, except now our first term is t1, or f of 1 is 2, and you plug in 2 here, and then 2 times 2 is 4, 4 minus 7 is -3. Then you plug in -3 here, 2 times -3, -6, -13, you plug in -13 here. So yeah, so you get it. So recursive formulas are formulas that depend on the previous term. Here is a nice fun example. In this example, not only did they give us T1, but they also gave us T2, because the equation they gave us depends on the previous two terms. So T3 is the next one, because we have 1 and 2. T3 is equal to T1, because this is 3 minus 2, and we know that 3 minus 2 is just 1. So T1 plus T, and then 3 minus 1 is T2. So the third term is equal to the first two terms added together. That's 2. What about the fourth term? Well, the fourth term is the same thing as T2 plus T3, the sum of the two previous terms. So that's going to be obviously 1 plus 2. So T4 is 3. What about T5? And you'll soon see that these numbers are going to jump up real fast, even though it's just addition. So T5 is the same thing as T3 plus T4. And T3 I know is 2. And T4 is 3. So 2 plus 3 is 5. And you keep going, and you'll see that the pattern is 1, 1, 2, 3, 5, 8, 13. This is actually called the Fibonacci sequence, and you can Google it. I highly recommend just doing a quick YouTube Google search and be like, cool facts about golden ratio or cool facts about Fibonacci sequence, and it'll be yeah, fun. Now those are all addition or subtraction type patterns. This is a recursion formula where you are using a common multiple or common ratio. Here we know -3, 6, -12, 24, and they're asking to write a recursion formula. So they're not asking you to write it in a formula that you've used before, that we learned before in the different lesson. They want it in this form. So Tn equals something times Tn minus 1. Well, the way to do this is this. We know T1 is -3. Always start the first term as just the value. Now, the second term has to do with T1 times something. We know the second term is 6. So 6 and -3, how are they related? Well, they're obviously related by -2. And then we know the next term is -12. And how is -12 and 6 related? Well, they're related by -2. So essentially what's happening is the pattern is you're taking the previous term and just multiplying by -2. So how do I write that? Well, I write Tn is equal to -2 times Tn minus 1, because n minus 1 basically means the previous term. Let's see if this works. So T1 is obviously 3. We always give the first value. So T2 is equal to -2 times T1. -2 times -3 is +6, and yes, that is the second term. The third term is going to be -2 times the second term, which is -2 times 6, which is -12, which is the third term. And the fourth term, the way we've written our equation, is -2 times the term before it, which is the third term. -2 times -12, +24, and yes, that is also the case. So we got our equation. So yeah, there we have our recursive formula. It is 10 a.m. now. You can graph it as well. So our functions are not continuous, because remember, it's 2, 6, 10, 14. So if you were to graph a sequence, it would look like this. It would just be points or dots on a curve. And that is it. So the last lesson I didn't go over, there's a bunch of videos. Go through it yourself. Good luck, everyone. Unit 4 test is due tonight. That's very important. Make sure you are completing and submitting on time. All right, good luck.